Our project is developing a framework for fluorescent data reduction and machine learning applications. Our sponsor, IPM, is hoping to use our project to launch their machine learning applications in their workplace for detecting pathogens such as HSV1 and HSV2, first starting off with head and neck cancer detection. And the two models we are going to be presenting are the probabilistic and predictive models.
Hi, I'm Siddhant Jain, and I'll be talking about the objectives of this project that we have. So firstly, we will be developing a web platform for the scientists at IPM so that they can upload their experiment files seamlessly. Second, that we are going to be deploying an end-to-end data pipeline and a storage system for them since they are currently lacking that. And finally, we are going to be developing an analytical dashboard for them to analyze their historical experiments and also any experiments that they conduct in the future, and also develop a machine learning model on top of it, as Mike mentioned. This is the framework that we have here. Our web app is going to be developed using Flask and JavaScript suite. Then going to be using the files that our scientists at IPM will be uploading. It will be going to the Dropbox as a backup and deploying all the data to MySQL to have a better database management system. And on top of that, we are going to be developing a Power BI analytical dashboard and create machine learning models using Python and scikit-learn.
Hello, I'm Aditya Vikram, and I'll be talking about the methodologies. And firstly, I would like to mention about relational database and file storage. So IPM deals with two types of files. One is machine generated and one is scientist curated. So machine generated files we call it as a raw data, and for the curated by scientists, we call it as sample info. So here are the tables that we will be working with. One is experiment, other is data, and other is sample. Now moving on to the web application, login and file upload. In order to upload the files, scientists needs to register on our web app using the Innotech domain. And once they register, they'll be seamlessly able to log in into the system and then upload the files using this upload dashboard. Now I would like to pass it on to my friend.
Hi, my name is Joe Calvasola, and I'll be talking about the data processing and statistical models that we've built. So once the data is input into the web application, it is then taken by our API and joined together to be processed and stored in our relational database. The machine-generated data as well as the user-generated data is also stored in Dropbox for later access by IPM. And then the data is then processed and used for our time series model is built to determine the time interval of a positive detection for specific specimens. Then the time to determine these specimens is then used as input for our probabilistic model, which it shows which specimens are exhibited a positive response and lets the scientist know which pathogens are present in a specific experiment. And so these two statistical models are built together to provide IPM a way to determine which pathogens are present in their model, in their data.
Hi, my name is Tanishq, and so combining all the methodologies, we were finally able to deliver our main outcomes that were a fully operational web application, a cloud-hosted relational database, and an analytical dashboard, which will help the IPM team to work more on their project. So our cloud-hosted relational database, so basically our MySQL database is then hosted and on AWS RDS, so all the scientists can look at the data. And our analytical dashboard, it shows the samples for all our experiments, and we have a filter that will help them drill down to a specific sample if they want to. And our machine learning framework, so basically the time series model will determine the inflection point using the sample data, and our future work is to implement it with the IPM data.